Good morning, students. So today I'll start with the second chapter, Basic Algebra. Second chapter, Basic Algebra. So capital N is a natural number. Natural number starts with 1, 2, 3 up to going on. Second one is Z. Z is a integer, negative to positive. -3, -2, -1, 0, 1, 2, 3 up to going on. Then capital Q is a rational number. Rational number, it is in the form of P by Q with denominator not equal to 0. Next one, R minus Q. R minus Q is an irrational number. What are the irrational numbers? Example, √2 is an irrational number. √3 is an irrational number. √5 is an irrational number. √7 is an irrational number up to going on. Now, so natural number starts from 1, 2, 3 up to going on. Integer, negative to positive. Capital Q is a rational number, P by Q with a denominator not equal to 0. R minus Q is an irrational number. √2, √3, √5, √7 this way going on. I'll start with exercise 2.1. Question number 1. √7 minus 1 by 4, 0, 3.14, 4, 22 by 7. Capital N is a natural number. Q is a rational number. R minus Q, it is an irrational number. Z is an integer. Exercise 2.1, first sum. √7. √7 is an irrational number. So R minus Q minus 1 by 4. Minus 1 by 4 is a fraction. It is an rational number Q. Next one, 0. 0 is an integer. 0 is an rational number. 0 is an integer. 0, no denominator, 1. 0 by 1, it is a rational number. Next one, 3.14, no denominator, 1. P by Q, that is rational number Q. Next one, 4. 4 is an natural number. 4 is a integer. 4 is a rational number because no denominator 1. The next one 22 by 7. 22 by 7 P by Q, that is rational number. Now I'll going to second sum. Prove that root 3 is an irrational number. Very very important sum. Prove that root 3 is an irrational number. Question number 2. Prove that root 3 is an irrational number. Before I'll given two important hint. Hint number 1. So P by Q. P by Q is a rational number with Q not equal to 0. P by Q is a rational number with Q not equal to 0. Hint number 2. Co-prime. We know that what is the meaning of the co-prime? There is no common. There is no common except 1. There is no common except 1. So co-prime means there is no common except 1. Example 2 and 3 are co-prime. 2 and 3 are co-prime because 2 and 3 there is no common except 1. Third hint, theorem. Here you want applying by the theorem. The theorem result is P divides A square. P divides A square. So P divides A. Now you want applying by this result. So totally 3 hint I'll given. Hint number 1. P by Q is a fraction with Q not equal to 0. Co-prime. There is no common except 1. 2 and 3 are co-prime. Theorem. P divides A square. P divides A. These 3 hint important. Now I'll going to second sum. Prove that root 3 is an irrational number. Irrational opposite rational. Let us assume that root 3 is a rational number. Rational number, it is in the form of P by Q or A by B with Q not equal to 0. A and B are co-prime. A and B are co-prime. Now we can cross multiplying. So root 3 into B equal to A. You removing square root, squaring on both sides. Squaring on both sides. Root 3 squaring 3. B squaring B square. A squaring A square. So 3 divides A square. Product inside divide. 3 divides A square. 3 divides A square. Now you want applying by theorem. P divides A square, then P divides A. Applying by the theorem. 3 divides A square, 3 divides A. Take it for equation number 2. What's the meaning? 3 divides A by 3. Dividing we get some constant C. Now we can cross multiplying. A equal to 3C. Substitute in equation number 1. From 1 implies 3B square equal to A square. 3B square equal to A square. 3C the whole square. 3B square equal to 3C into 3C, 9C square. How many times? 3 times. Now 3C square equal to B square. Product inside divide. 3 divides B square. Theorem you want applying. 3 divides B. Take it for equation number 2. From 1 and 2, 3 from 1, 3 divides A. From 2, 3 divides B. So from 1 and 2, 3 divides A and B. 3 divides A and B. 3 is a common factor, but already told A and B are co-prime. There is no common here, common. So therefore our assumption is wrong. So root 3 is an irrational number. Now I'll going to question number 3. Are there two distinct irrational number? You take two irrational number such that their difference is a rational number. Justify. You take two irrational number, you'll find the difference. So the difference is a rational number. So question number 3, you take two irrational number. Let x equal to a plus root b, one irrational number. Y equal to c plus root b, another irrational number. B two irrational number. B, two irrational number. The given question difference. These two subtracting x minus y, x a plus root b minus y c plus root b. So a plus root b minus inside multiplying minus c minus root b plus root b get cancelled. A minus c, which is a rational number. I'll give one example. I'll take two irrational number. X equal to 4 plus root 3, y equal to 2 plus root 3. Difference we can subtracting x minus y, x 4 plus root 3 minus y 2 plus root 3 minus inside multiplying 4 plus root 3 minus 2 minus root 3 minus root 3 plus root 3 cancel. 4 minus 2 2 which is a rational number. Now I'll going to fourth sum. Find two irrational number such that their sum is a rational number. You take two irrational number, sum we can adding, it is a rational number. Can you find two irrational number whose product is a rational number? First one, the sum is a rational number. Second one, the product is a rational number. Now I'll going to fourth sum. I'll take two irrational number. Let x equal to a plus root b, y equal to c minus root b, b two irrational number. B, two irrational number. Sum. The sum is a rational number. What is the meaning of the sum? We can add in these two. X plus y. X a plus root b y. C minus root b. Minus root b plus root b get cancelled. A plus c. So which is a rational number? I'll give one example. I'll take two irrational number. X equal to 4 plus root 3, y equal to 2 minus root 3. Sum we can add in. X plus y equal to 4 plus root 3 y 2 minus root 3. Minus root 3 plus root 3 cancel. 4 plus 2, 6. Which is a rational number. One more question. You take two irrational number. The product is also a rational number. You take two irrational number. X equal to 4 plus root 3. Y equal to 4 minus root 3. Product. These two we can multiplying. xy x 4 plus root 3 y 4 minus root 3. It is in the form of a plus b into a minus b. The formula is a square minus b square. A 4 square minus b root 3 the whole square. 4 into 4 16. Root square cancel 3. 16 minus 3 13. Which is a rational number. Now I will going to question number 5. Find a positive number smaller than 1 by 2 power 1000. Justify. Question number 5. We know that comparing 1000 and 1001, 1001 is greater. So this is for greater term. The given question, find the positive number smaller than 1 by 2 power 1000. 2 power rising power 2 on both sides. 2 power 1000 less than 2 power 1001. The given question, 1 by taking reciprocal on both sides. Taking reciprocal on both sides. Before I'll give one hint. So now 2 10. Which is the greater number? 10 is the greater number. Now you taking reciprocal 1 by 2. Reciprocal 1 by 10. 1 by 2 0.5. 1 by 10 0.1. Which is the greater number? 1 by 2. So taking reciprocal less than is automatically greater than. Here also the same thing only. Taking reciprocal on both sides. So 1 by 2 power 1000, 1 by 2 power 1001. Taking reciprocal less than is automatically greater than. Now we can comparing this two. This is the smaller term. So therefore 1 by 2 power 1001 is smaller than 1 by 2 power 1000. Exercise 2.1 completed. Then next I'll start with the exercise 2.2. Next I'll going to absolute value, modulus of x or absolute. Modulus means a value must be positive, a value must be negative. A value must be positive if x greater than or equal to 0. A value must be negative if x less than 0. This is important result for all the sums. This particular result only you want applying. Modulus of x is less than 1, minus 1 less than x less than 1. Now I'll going to exercise 2.2. First Roman letter, first sum. Modulus of 3 minus 6 less than 7. Now I'll going to exercise 2.2. First Roman letter, first sum. Modulus of 3 minus 6 less than 7. Already I'll given. So modulus of x less than 1. What is the hint given? Minus 1 less than x less than 1. So you want applying by the result. Here 7 is given. So minus 7 less than x. X is inside of the modulus. 3 minus 6 less than 7. Between x only coming, you removing 3, subtracting minus 3, minus 7 minus 3 less than 3 minus x minus 3 less than 7 minus 3. Why we can subtracting minus 3? Because between x only coming, you removing plus 3, subtracting minus 3. Minus 7 minus 3 minus 10. Minus 3 plus 3 cancel, minus x. 7 minus 3 4. Now you removing minus because between x only coming, multiplying by minus. Minus 10 means plus 10, minus x means plus 6, plus 4 means minus 4. Before I'll given one important hint. Minus 2, 3. Which is the greater number? 3 is the greater number. Now multiplying by minus. Minus 2 means plus 2. Plus 3 means minus 3. Now which is the greater number? 2. So multiplying by minus, less than is automatically greater than. When multiplying by minus, less than is greater than, less than is greater than. Now comparing 10 and minus 4, 10 is greater. So minus 4 less than x less than 10. So x can take the values minus 4 to 10. X belongs to minus 4 comma 10. That is the final answer. Less than given, open interval. Less than or equal to given, closed interval. Less than given, open interval. Less than given, closed interval. Suppose less than or equal to given, of open, of closed. I'll go into first Roman letter, second sum. Modulus of 4x minus 5 greater than or equal to minus 2. Now modulus of 4x minus 5 greater than or equal to minus 2. Now you take any values. I'll take it for -1, 0, 1. First, when x -1 substituting, 4 into -1 -4, -4 -5 -9. Modulus of -9 is 9. 9 greater than or equal to -2. The condition is correct because modulus means a value cannot be negative. Next, 0. 4 into 0, 0. 0 minus 5, -5. Modulus of -5, 5. Greater than or equal to -2. The condition is correct, 5 only greater. X 1. 4 into 1, 4. 4 minus 5, -1. Modulus of -1 is 1. 1 greater than or equal to -2. The condition is correct. Any number substituting, the answer is correct. Therefore, solution set equal to, solution set equal to set of real numbers. Solution set equal to set of real numbers. Now I'll go into first room letter, third sum. Modulus of 3 minus 3 by 4x less than or equal to 1 by 4. I'll go into third sum. Modulus of 3 minus 3 by 4x less than or equal to 1 by 4. Already I'll given the hint. Modulus of x less than 1. So -1 less than x less than 1. Now removing the modulus here, 1 by 4 given. -1 by 4 less than, inside of the modulus, 3 minus 3 by 4x less than or, because less than or equal to given, less than or equal to 1 by 4. Already told, between x only coming. First you removing 3, subtracting -3. -3 minus 1 by 4 less than or equal to 3, subtracting 3, -3, then 3 minus 3 by 4x less than or equal to -3 plus 1 by 4. We can cross multiplying, 4 3s are 12. -12 minus 1 minus 13 by 4 plus 3 minus 3 cancel, -3 by 4x. Cross multiplying, 4 3s are 12. -12 plus 1 minus 11 by 4. Already told, between x only coming, you removing -3 by 3, multiplying -4 by 3, -13 by 4 into -4 by 3 less than or equal to -3 by 4x into -4 by 3 less than or equal to -11 by 4 into -4 by 3. 4 4 cancel, minus get cancel, 13 by 3 less than or equal to 3 3 cancel, 4 4 cancel, minus into minus plus x less than or equal to 4 4 cancel, minus into minus plus 11 by 3. Comparing this to 11 by 3 is the greater term. Now already told, when multiplying by minus, less than or equal to is automatically greater than or equal to, less than or equal to is automatically greater than or equal to. So greater than or equal to, greater than or equal to. Comparing this to 13 by 3 is greater. So 11 by 3 less than or equal to x less than or equal to 13 by 3. So 11 by 3 to 13 by 3. X belongs to less than or equal to given of open of closed 11 by 3 comma 13 by 3. That is the final answer. So today I'll going to the last sum, first room letter, fourth sum. Modulus of x minus 10 less than minus 3. Now fourth sum, modulus of x minus 10 less than minus 3. Minus 10 inside plus 10. Modulus of x is less than minus 3 plus 10. Modulus of x less than 10 minus 3, 7. Already I'll given the hint. What is the hint I'll given? Modulus of x less than 1. So minus 1 less than x less than 1. You want applying by the result. Modulus of x is less than 7. So minus 7 less than x less than 7. The value become minus 7 to plus 7. X belongs to minus 7 comma plus 7. Less than given open interval. So thank you children.